Welcome to Module 24 on Line of Best Fit. Make sure you have your notebook out, ready to take some notes. Today we're going to be talking about how to construct a scatter plot, how to sketch a line of best fit. We're going to discuss scatter plots and correlation, and we're going to make some predictions. So turn to a new page in your notebook and write at the top, Module 24, Line of Best Fit. And I want you to put a new topic, constructing a scatter plot. So when you collect data in real life, it rarely falls along nice, neat lines. So what we've got is the amount of shrimp and the amount of beef bought by each of 7 people. So there are 7 pieces of data, but that has nothing to do with what we're graphing. That just means we'll have 7 points. What we're actually graphing is the amount of shrimp compared with the amount of beef. We're going to graph these as coordinate points, 1, 7. And don't forget, this is your x and this is your y every time. So we go over 1 and up 7 and put a dot. 3, 8, over 3 and up 8 and put a dot. 6, 12, over 6 and up 12 and put a dot. And notice these are not now along a nice, neat straight line. That's because this is real life data. Real life data likely will not make a nice, neat straight line when you collect it. Oops, that should be over here at 8. Sorry about that one. 9, 3, 10, 10, and 13, 6. So this is definitely not a nice, neat straight line. In fact, if you connect it with a line, you will be wrong. A scatter plot just shows the relationship between two things. And for this, it seems fairly random. It doesn't seem like there's much correlation between the amount of shrimp and the amount of beef. These don't even approach a straight line in any way. You pause the video and see if you can make your own scatter plot on your own. Go ahead and do that now. All right, you should have graphed the age on your x-axis, the height on your y-axis, and you should have treated each of these as a coordinate point, 4, 6, 5, 8, and so on. This is your x-axis, this is your y-axis. So again, these do not make a nice, neat straight line, but we can start to see more of a relationship. It makes sense that your age in years could be related to your height, especially when we're looking down here at the lower ages. You're definitely going to grow a lot as you age, but that's not perfect. That's why it doesn't make a nice, neat straight line. Everybody isn't the same height when they're 14 years old. It's just not how life works. But we can start to see a relationship. And what we're going to talk about next is how to make a line that represents that relationship. So new topic, sketching a line of fit. So I would recommend that you not make this whole scatter plot perfectly on your paper. If you're trying to write it down, what you can do is just make an approximation of the points, something that looks like that, and that's good enough for me on this. This will give you what you need. So what we've got here is time spent watching television compared with time spent doing homework, and we can see that there is a relationship. As time spent watching television increases, time spent doing homework decreases, because as we move from left to right, the dots move down the graph. What we can do is draw a line of best fit, and that will help us to make some predictions about those relationships. And so generally what I tell people is it's a line as close as possible to the middle of your data points. So it should look something like that. You should have about half of the dots on top and about half of the dots on the bottom, and it should move in the direction of the data. So now, let's improve upon that. New topic, scatter plots and correlation. So generally in life, you will not be asked to draw your own correlation line or your own line of best fit. You'll use software or a program to do that for you because the calculations on it are really intense, or you just have to end up estimating, which isn't very good. So typically what statisticians do is they have a computer draw their line of best fit for them. So we've got a comparison of weight and fuel efficiency. So you can see that your slope is negative on your line of best fit. That means as the weight of the car gets larger, the fuel efficiency decreases. It goes down. So for these 24 vehicles, as weight increases, fuel efficiency tends to decrease. And again, when you draw this on your own graph, please do not spend a bunch of time to make a perfect graph on your notes. Do something like this. Draw your line in, put weight on your x-axis, put fuel on your y-axis, and that's good enough for you to be able to answer these questions. For these 24 vehicles, there is a blank correlation between weight and fuel efficiency. So what they're looking for there is either positive or negative. And if you use slope, that will help you with this. This line has a negative slope, which means I should say that this has a negative correlation. We already talked about that because as the weight increases, the fuel efficiency decreases. And then we can use our line of best fit to make some predictions. We could predict that a vehicle weighing 3,500 pounds, so that's about right here. That's 3,500 pounds. And we want to follow it up to our line of best fit. We don't want to follow it up to the X. We want to follow it up to our line of best fit, which is about right there. If I follow that over, I can see that's about halfway in between 25 and 30. Well, that's 26, 27, 28, 29. So halfway in between, you could either say 27 or 28, or you could say 27.5. I assume on this drop-down box, you would have some options here, but I would probably say 27.5. If it's not close, if that's not one of your options, then you could choose 27 or 28 and be fine on that one. Again, you're just looking for an estimate. This isn't perfect. You're not going to go out and find a 3,500 pound truck that has exactly 27.5 miles per gallon, but it should be pretty close to that. All right, you pause the video, see if you can answer these questions on your own. So this looks really similar to what we just did. The questions are a little bit different. For these 21 vehicles, as weight increases, fuel efficiency tends to decrease. Remember, we talked about you can tell what that is because of the negative slope. That means there is a negative correlation. And then when you made your prediction, it says, using the line of best fit, we would predict that a vehicle weighing 4,000 pounds, so we're going to follow up to the line from 4,000. That's about right there. And again, that's not perfect, but if we follow that over, a vehicle weighing about 4,000 pounds should have a fuel efficiency of approximately 25 miles per gallon. All right, new topic, predict from line of best fit. So we were just making some basic predictions, and overall, those would probably be pretty good if we actually collected some data. But the computer can actually create a perfect line of best fit equation for you. So what we've got here is back to our original graph of time spent watching TV and time spent doing homework. So they have written us an equation with a perfect slope and a perfect y-intercept for this line of best fit. This is much better than what you or even I could do if we were trying to calculate the line of best fit by hand. What that means is we have a negative slope and a y-intercept, if we were to follow this up, of 26.04. So this says for an increase of 1 hour in the time spent watching TV, what is the predicted decrease in the time spent doing homework? Well, remember, time spent watching TV is on our x-axis. They're telling you that x is going up by 1. What is happening to the time spent doing homework? Well, that's our slope. That's a rate. That means that our decrease is negative 0.76. So it's going down by close to an hour, but not quite an hour. Then it asks you to make some predictions. What is the predicted time spent doing homework for a student who doesn't spend any time watching TV? What they're telling you is x equals 0 there. Well, that's your y-intercept. If you don't recognize it, you can go ahead and substitute it in. This just becomes 0. 0 plus 26.04 is 26.04. And that's it for that one. And then it asks, what is the predicted time spent doing homework for a student who spends 15 hours watching TV? So again, that's you that x is equal to 15. So we're going to substitute in negative 0.76 times 15 plus 26.04. That gives me negative 0.76 times 15. That gives me negative 11.4 plus 26.04, and that gives me 14.64 hours. So what that's telling me is if I could predict that somebody's TV, that they're going to do about 14.64 hours of chores. So the 14.64 would go there. You pause the video and try to answer these questions on your own. So you should have taken a look at your graph first. What we've got is a negative correlation. The line of best fit goes through the middle of the points. On the x-axis, we've got time spent texting, and on the y-axis, we've got time spent exercising. So it looks like as time spent texting increases, time spent exercising decreases. So for an increase of 1 hour in the time spent texting, what is the predicted decrease in the time spent exercising? Again, that's a comparison of two things. You are comparing an increase in 1 hour to a decrease. So you are decreasing by 0.74 because this is a rate. This is your slope. Then it says, what is the predicted time spent exercising for a student who doesn't spend any time texting? What that's telling you is x is equal to 0. Well, that's your y-intercept. If you didn't recognize it, you could go ahead and substitute 0 for x, but you still end up with the intercept because this times 0 is 0, plus 8.74 is 8.74 hours. But here we have to actually solve something. What is the predicted time spent exercising for a student who spends 6 hours texting? Well, I can make a pretty good estimate. It's going to be somewhere between 4 and 5, but I can actually substitute in and solve. Y equals negative 0.4 times 6 plus 8.74. So I'm going to put that into my calculator. Negative 0.74 times 6 plus 8.74, and I get 4.3. So again, I had a pretty good estimate. If I follow this up to 6, it's somewhere in between 4 and 5, which is where 4.3 is. And you're done. This will be available on Haiku if you need to rewatch, and will be available on each skill for Module 24 in ALEKS. You should now complete Module 24 practice problems in ALEKS by selecting Continue My Path. Don't forget there's an explanation on each ALEKS problem, and you'll need to complete Quiz 24 when you've done all the practice. Have a great day.